Okay, good morning, peoples. Whoever listens to my thing and watches my videos, thank you, I guess. It's nice. Anyways, so today let's talk about compactification. Let's just get straight to it because you know how I play. Okay. Usually, simple compactification is like, let's say, arbitrary 0, 5. Boop. We loop this. And now that's compact. It's been closed up. And what you get is sort of like a modulo thing, right? Where the highest you can go is 5. Because as soon as you go from past 5, then you're back at 0. Or 5 and 0 are the same place. So that at 5 you are 0. So as soon as you go past 5, 5.01 is actually 0.01. Which, I don't do it, but this normalization process seems like pretty much very similar, that you've applied a modulo of whatever this extreme is, and now you come back and you make your calculation of whatever's left over. So now that's one-dimensional. And often for a two-dimensional representation, what you would have is sort of the really bad quality. Well, circle color. There we go. Is a circle, a Riemann though. So let's go like this. We'll do the projective plane, because what ends up happening is, you have a measure, the grid, or whatever, right? This would be a two-dimensional surface now. We're going to be wrapping. That was 1. We're going 2. And what happens is these map onto like that, but these get denser and denser and denser. So what you end up with is a sphere where it's like, here's maximal density, and then the density lowers because you'd be projecting from here to infinity, and that has to cover a really big area, and like that, roughly. Maximal to minimal. So now we have I sort of just did the sphere one. But that's the thing. When you do it two-dimensional, you wrap onto a sphere. Now, what we live in is the three-dimensional version of that. So what measure are we going to use, let's just say? Because the universe displays low density to very high density, but there seems to be a maximum here. Like there's a limit. But the thing is, these two limits are supposed to join also. So we have to, if we took a Shirley surface type thing, we push this down to here, we push this up to here, and now what we have is like a torus where there's a gradient, right? This is this is actually the low one. So we'll just do that's just 1. But this side is like, so this would be the convergent side, because this is where the density increases. And this would be the divergent side, or the low pressure side of this shape. But I suggest that, okay, so the universe seems that it's compactified in some way. If we were just compactifying space, let's just say, we're compactifying space, so you have density. But don't we know from our playing with the material world that m equals E c squared. Mass is made out of energy. So density of space is actually density of energy. And how do we measure energy? I suggest it's a function of time. It's like the amount of action that takes place over any given time unit. You know, the amount of charge that passes over a given time unit. And we see it as an intensity because it's an intensity of flow. So this is why I suggest that time is compactified. Okay, but we also have been playing around with the universe and believe that, there's this antimatter stuff. There's a whole bunch of stuff that's very much like us. In fact, identical to us, but kind of flipped over, flipped inside out. So, how do we represent this? Because the place where matter and antimatter seem to connect is at the maximal end of things. It's not at the minimal end of things. Like when you have a low energy situation, you're very unlikely to be just like have antimatter pop up. But when you create a very, very high energy situation, you might. So let's make this line maxima, okay? And we're going to go like this. And we're going to have to imagine that this is 360 degrees, okay? And this is 360 degrees. There's 360 degrees in the matter universe. There's 360 degrees in the antimatter universe. And they are connected by time, right? Or this membrane of intensity, the maximal, which I suggest is time. And it's sort of like a good way of envisioning it is like a spinning top, a single spinning ball. And we'll have this minimal because at the pole, if you're standing right at the pole, you're only spinning, but you're staying in place. It's like you're spinning, but you're not actually traversing any distance while you do that. And then as you go down, because you cover more distance, this is like at the equator, the speed, the velocity here is the very highest. So this is the joining place, the equator. This is the highest speed. This is C. This is where shit is going, happening. This is the surface of a neutron. This is the surface of a proton. This is, electrons we know are actually up here someplace, away from this, because they only get like 1/127 point of the speed, according to, wasn't that the Bohmian description of it? That's basically, if we just think of electrons as going 1/27th the speed of light, that accounts for the sort of the size and the energy compared to a proton who lives down here. So I don't know about this geometry, how that math plays in, but the principle is this is very low, this is very high. So this is the very highest density, and then it gets less and less and less, right? So this is the highest velocity. This is where time is going. It seems like it's going slow from here, but I suggest actually it's going fast. It's just like because space gets compactified, arc visual distance shrinks, and therefore it looks like things aren't going. But everything has to go at C, right? It's like they're all covering the sphere, but it's just your interaction. It's almost like your angle of approach to the sphere is what's relevant. Your angle of approach to time. How close are you to time? We're on the surface of time. Like there's so little energy around where we are that we can even see through it easily. You can't see through a solid steel, not so good. And steel is still like foam compared to neutronium. So we got to keep a perspective on these things. So this is my suggestion, is basically like this is a good way of envisioning it. Here is an antimatter, and I'm going to do it lambda for the universe, anti-universe, universe, right? And let's just imagine, we'll just pick an arbitrary direction for this rotation, right? So if you live on this side, on the matter side, and you look down at your universe, it is going, we'll say, counterclockwise. It is just arbitrary, because we don't really know what side we're on. We could be on the antimatter side, only we think it's matter because we're on the side that it is. So, going counterclockwise. But if you are from the antimatter universe, and you look this direction, because that's the direction of density, just the same way you look this direction on this side, what you see is the universe going to you clockwise, even though they're both going the same way, because they're a unity. Every electron is a positron. You know, these things, we all have our antis. We only get half the bestiary. This is 360 degrees, 360 degrees, 720 degrees. This is how this came about. This is why it is. It's a very clear geometric relationship about these things that we've been given. And it says to me, at least, that the universe, time is compactified. Because time is compactified, there are limits, minima and maxima. Okay? But those limits have to join. So what happens is, so this is good for envisioning this, but why I apply Shirley's surface for the actual larger flow, because the minima and maxima have to join. And what Shirley's surface does is, being a single-sided surface, I'm sorry that it's infinity. It's not my fault. It's just geometry. What can I say? How are we? Okay, a little bit of shine. I don't know, this is getting rambly. Okay, so these were 2 minutes, but now time isn't there. Time is this membrane, right? Because this is the shape of the universe. So time is actually the membrane. And this is minima, and this is maxima. And what happens is, a neutron explodes and becomes freaking huge. Well, first it just becomes a proton and an electron, but that is actually hydrogen. So it sits around for a while as dark matter. After a while, it starts to coalesce, becomes a nice little hydrogen atom, monatomic hydrogen, large clouds of which are found around galaxies. It's all over the place, but it's exactly where you expect it to be. It's where the stuff has fallen and starts to become monatomic hydrogen. Because just a little closer to the filaments, this hydrogen becomes, molecular hydrogen. And then it keeps on falling all the way down here towards maxima, getting denser and denser until it hits here. And all matter, because of electron capture, is basically forced to turn back into a neutron by the time it hits the event horizon, because it needs to be a neutron so that it can go from maxima to minima, from event horizon to void, and do the cycle again. And this is like the crux of time. This is the fastest point of time. That's the node of time, 1 Planck unit just floating there in space that everything is attracted towards because it's so intense. And we're all sort of looking at the surfaces that are heading towards it at different speeds. And yeah, so that was very rambly and stuff like that, but hey, I'll put it together. And what I'm going to be able to do after chatting with ChatGPT and thinking about it is using Shirley's surface, because Shirley's surface is essentially like the spinner shape, right? And what we have is, so if we have this as convergence, and we make positive convergence because it's fluid dynamics on a dielectric superfluid. So there's compression here. These have been pulled from here. We have a positive charge here, a negative charge here, electron, positron. That's the charge version. And then once it's become little granules of nuggety neutrons and coalesced into hydrogen, well, it's the granular form that does exactly the same thing. And that's like that's the black hole at the center of Sagittarius A, and we are about here someplace. This is like filament. I bet filament is all this. Filament is only a certain angle. We could even calculate it. It's just, what's a density? This is the maximal density event horizon. That's minimal density lambda. There's a range. We know there are limits. Therefore, we should just have a graph, and everything can fall someplace on this graph of energy density, because that's what it all comes down to. Anyways, peace. I know rambly, but like I said, I'll have something more, concise soon. Bye.